So we're looking at matrices now. In matrices, somebody preparing for the test or exam, just have a few things to look at in matrices. One, how to find the determinant. Or first, how to determine the order of matrices. And then two, determinant. And then three, Cramer's rule. And then four, inverse method. When you're done, these are the only four major things, because if you can know the order, if you're able to tell what the order is, then you can tell if you're able to add, subtract, multiply the matrices given. Are you able to tell whether you can find the determinant? And if you can find the determinant, then you can use Cramer's rule, because it's just a rule of determinants. And then you understand the inverse. When you're done with matrices, nothing else can be asked from matrices apart from that. Where these two, we'll talk about systems of equations. So part one of this class is talk about the order of the matrix. Order of matrices. The order of a matrix. Okay, so the order of the matrix A. So if A is a matrix, say 1, 2, 3, 4, 7, -1, 0, 3, 2. When they say find the order of A, you count number of rows multiplied by number of columns. That's the order. So in this case, the order of A is going to be number of rows. We mean these lines. 1, 2, 3. So you write 3 multiplied by number of columns. 1, 2, 3. So 3 by 3. And the 3 by 3 matrix, these matrices where you find that the number of rows is equal to the number of columns are called square matrices. Okay. If you are given B, 1, 2, 3. What's the order? So you say this is a 1, 2, 3. So 3 by 1 column. So 3 by 1. C. You have a matrix 1, 2, 3, 4. -1, 0, 3, 2. The order, this is a 2 by 1, 2, 3, 4. 2 by 4. That's the order. So this is a 2 by 4. This is a 3 by 1. And then a 3 by 3. So counting, so then one need to know that one, you can only add or subtract matrices of the same order. Two, okay, that multiplication of matrices A cross B, which is also written as AB, is only possible if the orders are of the form, if A is M by N, we require that matrix B be N by whatever. Okay. We want the number of columns in the left matrix to be equal to the number of rows in the right matrix. And the answer you get here, the matrix you get, its order will be M by P. So this will be the order of a new matrix. The product matrix. Very easy. So you check when they tell you to multiply, you just check the order and then be able to start multiplying. So let's do examples based on this. Or do I have any questions? I'm giving you time to screenshot it. Okay. Examples. Let me check if we have so question. So if we go to drill sheet 8, question 2, suppose we are given the following two matrices. We have A and matrix B. So as you can see, A is a 3 by 3 and B is a 3 by 3. And then they are asking us to compute A minus 5B. Compute A minus 5B. So because the orders here will be the same, we are able to do this operation here. So go straight and do the operation. So one, given A is equal to 3, negative 2, 4, negative 9, 1, 5, negative 3, 2, 1, and B is negative 4, 1, 6, 0, negative 5, 2, 1, 4, negative 2. Negative 3, I mean. Negative 3. Compute A minus 5B. So we're doing two things here. We'll do the subtraction and also scalar multiplication. So we're starting with scalar multiplication before we subtract. So we do A. So A minus 5B. This is equal to A 3, negative 2, 4, negative 9, 1, 5, negative 3, 2, 1, minus 5 multiplied by matrix B, negative 4, 1, 6, 0, negative 5, 2, 1, 4, negative 3. So here, what do we get? We first multiply matrix B with a scalar 5. So that will be minus. Then we multiply now 5 by all the entries inside. So 5 by negative 4, we get negative 20, 5 by 1, positive 5, 5 by 6, 30, 5 by 0, we get 0, negative 25, 10, 5, 20, negative 15. Then now you subtract each entry where it is sitting minus the entry sitting at the same position in another matrix. So the first one minus the first one. So we have 3 minus 20. That would be 3 plus 20, which is 23. Then negative 2 minus 5. That would be negative 7. Then 4 minus 30, we get minus 26. And then negative 9 minus 0 is negative 9, 1 minus 25, 26, 5 minus 10, minus 5, negative 3 minus 5, that's minus 8, minus 18, 1 minus, that is positive 16. So that's how we get the matrix there. So you check before you start adding or subtracting, check if the orders are the same. And then go on and do the calculations. Okay, what about multiplication? As example 2. In the throw sheet is question 3. So suppose that A is equal to 2, negative 1, 0, negative 3, 6, 1, and B is 1, 0, negative 1, 2, negative 4, 3, 1, 0, 0, 3, 0, negative 2. Compute AB. So AB is equal to, we check the order. What's the order of A? 2 by 3. And we are multiplying it with B. What's the order of B? 3 by 4. So we know because 3 is equal to 3, these two multiply and give us a matrix of order 2 by 4. So we go on and prepare for multiplication. 2, negative 1, 0, negative 3, 6, 1. Multiplied by 1, negative 4, 0, 0, 3, 3, negative 1, 1, 0, 2, 0, negative 2. This is equal to, now how do we multiply matrices? So you multiply this row here, the first row, by the first column to make the first entry. Make just one entry. Again, the first row by the second column. So each row will go through all the columns for you to form a new matrix. So let's see, we're starting with the first one now. So 2 times 1, we get 2, plus negative 1 times negative 4, we get 4, plus 0 times 0, we get 0. This is the first entry, this one. The second entry, 2 times 0, 0, plus negative 1 times 3, we get negative 3, plus 0 times 3, we get 0. Next, 2 times negative 1, we get negative 2, plus negative 1 times 1, we get negative 1, plus 0 times 0, we get 0. Another one, 2 times 2, we get 4. Negative 1 times 0, we get 0. 0 times negative 2, we get 0. Close. We come back. Negative 3 times 1, we get negative 3, plus 6 times negative 4, we get negative 24. 1 times 0, we get 0. This times that, we get 0, plus 6 times 3, 18. 1 times 3, 3. Then 6 times negative 1. Sorry. So it's negative 3 times negative 1. 3, 6 times 1, 6, and 1 times 0. And then negative 3 by 2, and then by 0, and then by negative 2. Okay, so since this is done, so I need to reduce size of my project here. Okay. So now you're forming a matrix. Remember we said it's 2 by 4. And as you can see, it's 2 by 4 for sure. So 2 plus 4, 6. And then minus 3. Like that. And then minus 3 again. And then 4. And then minus 27. And then 21. And then 9. And then negative 8. So this is a product matrix, and for sure, it's a 2 by 4. So just here, I give you an exercise. So if A is equal to 1, 2, 3, and B is equal to -1, -4, 8. Compute 1 AB and 2 BA. Yeah, what? A nice one for you there. Well, we're becoming a bit serious now because we're going towards the exam. So it should be a serious condition that if you don't do this question, hello.
Yeah, since you said we only multiply if the orders is the same. Now, if the order is not the same, what do you do?
You say that it can't be multiplied because the orders do not allow multiplication.
Okay. So I just end there.
Yeah.
All right, thank you.
So I'm saying that submission of the task has now become very important. Very important for the sake of progress, and most importantly, is so you need to submit them before the next class tomorrow. On Wednesday, or else there will be no peace. This is exercise 1. Exercise 1 on matrices. Page 2. So we're going to page 4 now. This submission is whether you have attended or you're just watching and you're part of the class. Watching is equivalent to attending somehow. Part 3, so part 2 now, we talk about determinants. How do you find the determinant? Okay. First, of a 2 by 2 matrix. So if A is A, B, C, D, then you say the determinant of A, which sometimes will just be denoted as, you just find they've put the matrix in these lines. That looks like absolute. Then you know they mean the determinant. So how do you find the determinant? You multiply A times D, A times D, minus B times C, minus B times C. This number you get here is the determinant of A. 2, 3 by 3 matrix. This one, first, you take care of the invisible signs. Okay, the cofactor matrix signs. So you know that for 3 by 3, you have plus, minus, plus, minus, plus, minus, plus, minus, plus. This, the entries that you see, behind them, there are these signs. That if you want to get the determinant, you use these signs. And then how do you find it? Suppose the matrix A is given as A, B, C, D, E. Okay, for this one, I won't demonstrate. I won't give you a general form to look as though it's there. So here we'll just do examples, then I'll demonstrate. That will be easy for us to understand. So let's go straight to examples. Okay. 1. Find the determinant for A. Matrix A is given as 1, 2, 4, 7. And B, matrix B is given as 2, 0, negative 1, 1, 1, 3, negative 1, negative 2, 1. Like that. So what's the determinant of matrix A? Well, the determinant of A is equal to 1 times 7. So 7 times 1 minus 2 times 4, which is 7 minus 8, which is negative 1. And the determinant of B is, so now for a 3 by 3, you choose either a row or a column, only one. So if I choose the first row, remember I have those invisible signs in the first row. So I get plus and then pick this number 2 as it is here, 2, and then remove the column where 2 is and the row where 2 is. The matrix that remains here. Okay, I write it here. I'll find its determinant 1, 3, negative 2, 1. So its determinant I'll multiply by 2. Minus. So minus, I pick this number 0, I put it here. And then remove it. So now I remove the column and the row. The matrix that remains 1, 3, negative 1, 1. I'll find its determinant. Plus, that plus there. Then I pick this number negative 1, negative 1. And then I remove the row and the column where negative 1 is found. The matrix remaining here. 1, 1, 1, negative 1, negative 2. I'll get the determinant and then multiply by negative 1. So now what we have 1 minus 6. That is 7. 7 times 2. So now we have 2 by 7. And then next, this is 0 here. So we just put 0 without finding this number. Because even if we find it, multiplied by 0 is 0. And then minus, this is negative 2 minus 1, meaning negative 2 plus 1. So we get negative 1 again. So we have 14 plus 1, which is equal to 15. This is the determinant for matrix B. Or even if we chose the second row, the third row, the first column, the second column, the third column, you would still find the same 15 as the determinant. It should be easy to find the determinant of the matrix. I don't expect it to be a crucial deal. Yes, we are still coming back for the determinant. As we'll be looking at the inverse in question 5, and then the inverse to solve the system, and then Cramer's rule in the next class. So this is 1834, so 1840. We should be able to join again. Hello.
I'm sorry, sir. I get confused a bit on when do you pick those negative and positive signs you are indicating here on top here?
When getting the determinant 1, and when getting the cofactor matrix.
Okay, then on 0, why did you indicate a negative there?
I indicated because it was there on those invisible, but I knew that 0 won't do anything. So I just indicated there for the sake of demonstration.
Okay.
Yeah, but when there's 0, is as good as just keeping that open.
Okay. Then it's not like in the first case where we had 2 by 2 matrices where we were subtracting the what? The minor and the multiplication of minor diagonal and major diagonal.
Major minus minor.
Like in the first case, we are subtracting. After multiplying these, we subtract. Here I've seen you've indicated plus the negative 1.
So when getting them, you get them with these signs. And then the inner matrices are the ones you're getting the determinant, right? Because the inner matrices are 2 by 2. For those you get the normal determinant, like they will get the normal determinant for 2 by 2.
Oh, okay.
Okay.
Thank you.
Okay. And somebody says on the multiplication of matrices. So here the key thing is you are multiplying the first row by all the columns of the second matrix to form the entries. The first row by the first column, entry number 1. The first row by the second column, entry number 2 in the first column. The first row by the third column, entry number 3. The first row by the fourth column, entry number 4. Again, just like that. In between, you're putting plus, 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 plus. And then you have your matrix. And don't forget the exercise there. About the order, if the orders are not the same, I mean, if the order is not, remember we are saying you can only multiply 2 matrices if the number of columns on the left matrix is the same as the number of rows in the second matrix. Then you can multiply. So if these are equal, then you can multiply here. And the order of the new matrix will be M by P, like that. Okay, so let me check the time we're supposed to join. This is date 7 now. Okay, so we join at 1850. Exactly. So keep time. Because we're trying to keep time here. In fact, in this, how many minutes? 17 minutes. 10 plus 3. 10 plus 2. 12 minutes, you'll be doing the exercise. Exercise 1. Apply A and B and then BA. So that when you come back, you would have submitted the solutions. You're just submitting on my inbox. We are 13 here, so I have the solutions. 13 messages. That's all. Just one page.